To get a picture of how our circuit works over time, we're going to use transient analysis, which lets us basically make oscilloscope plots of voltage waveforms and current waveforms. What we'll need to do is to add voltage and current probes to our circuit so we can see the plots of voltages and currents versus time. And the simulator uses basically a numeric simulation technique to work out how the circuit behaves. Okay, so here we have the circuit diagram from before. I've removed the current probes. What I'd like to do now is to go ahead and add some voltage probes to the circuit. So I'm going to come over here and click on voltage probes and drag this guy onto the circuit. So this will be, I'd like to make this a blue waveform. And then for the output of the battery, and then for the middle node of the voltage divider, let's make that a red waveform. And just so we have something interesting to see, I would like to change my voltage source to a sinusoidal voltage source. So it's plus and minus 1 volts around an amplitude of the 0 volt center line, which is just fine. I'm going to ask for 100 hertz sine wave. Okay, so now if I go off and ask for a transient simulation, I need to choose the length of the simulation. In this case, I'd like to see 2 oscillations of the 100 hertz waveform, so we'll simulate for 20 milliseconds. So here's the waveform. You can see that the output voltage of the battery is plotted as in blue, and the voltage of the middle of the resistor divider, which should be about a quarter of the voltage of the battery, is plotted in red. By moving the cursor back and forth on the screen, I can take a measurement at any given point. So you can see at this point we have a very close to 1 volt on the output of the battery and about a quarter of a volt at the out in the middle of the voltage divider. I can go ahead and simulate for different lengths of time. I can add more voltage and current probes and get them all to plot on the same screen so I can see over time how current and voltage are related, so forth and so on. A very handy tool for exploring the behavior of your circuit.